1937, Hamburg, Germany. The design submission landed on the desk at the German Aviation Ministry with a thud that would echo through aviation history. Officials stared at the blueprints in disbelief, some reportedly laughing, others shaking their heads in dismissal. The aircraft depicted on those technical drawings appeared fundamentally wrong, as if someone had assembled two different planes and forgotten half the parts. One side carried a massive radial engine attached to a fuselage boom extending back to the tail. The other side held a glass-enclosed gondola jutting out into empty air, housing 3 crew members in full view. No centerline, no symmetry, no conventional logic. This was the Blohm & Voss BV-141, and it looked like it had no business flying. Yet this bizarre asymmetrical reconnaissance aircraft would become one of World War II's most fascinating engineering experiments, proving that sometimes the strangest solutions emerge when conventional thinking fails. The story of the BV-141 begins not with acceptance, but with rejection, mockery, and one designer's stubborn conviction that aircraft didn't need to be symmetrical to fly straight. Blohm & Voss entered the 1930s as a respected Hamburg shipbuilding company with limited aviation experience. Their specialty was seaplanes and flying boats, leveraging their maritime engineering expertise to create aircraft that could operate from water. Walter Blohm, the company's visionary leader, recognized that aviation represented the future of transportation and commerce. He believed military flying boats would transition to commercial seaplane passenger transport after inevitable future conflicts, prompting the company to design with dual-purpose capabilities in mind. This forward-thinking commercial strategy positioned Blohm & Voss to explore unconventional designs that traditional military contractors might dismiss. By 1937, they had acquired Hamburger Flugzeugbau and brought aboard its chief designer, a World War I veteran named Richard Vogt, who would soon challenge every assumption about aircraft configuration. Dr. Richard Vogt arrived with credentials that commanded respect despite his reputation for unorthodox thinking. Born in 1894, he had served as both infantryman and aviator during the Great War, emerging with first-hand understanding of combat aircraft limitations. By 1937, he possessed over 10 years of aircraft design experience, having worked for multiple German manufacturers, developing both conventional and experimental designs. Colleagues described him as ambitious, outspoken, focused, and driven by a unique vision for aviation innovation that often clashed with established practices. Vogt believed that truly solving design problems required abandoning preconceptions about how aircraft should look. When the German Aviation Ministry issued its specification for a new reconnaissance aircraft, Vogt saw an opportunity to prove his radical theories about asymmetrical design. The fact that Blohm & Voss hadn't been officially invited to participate only strengthened his determination to create something unforgettable. The German Aviation Ministry's specifications seemed straightforward enough. They demanded a single-engine, 3-seat aircraft for short-range tactical reconnaissance, with excellent visibility for pilot, observer and rear gunner. The emphasis on a single engine reflected both economic reality and operational doctrine. Germany's aircraft industry couldn't waste resources on twin-engine designs for every role, and a single engine meant lower fuel consumption, simpler maintenance and cheaper production costs. The visibility requirement proved more challenging. Reconnaissance crews needed unobstructed views above, below, forward, and to both sides for spotting enemy positions, troop movements, and potential threats. Traditional single-engine configurations placed the engine directly in front of the cockpit, creating a massive blind spot. The pilot sat behind the engine, wings blocked side and upward views, and the fuselage structure limited rear observation. This visibility problem had plagued reconnaissance aircraft since aviation's earliest days, but most designers accepted it as an inevitable compromise. The competition attracted Germany's established aircraft manufacturers. Arado Flugzeugwerke submitted the AR-198, a conventional high-wing monoplane that looked like every other reconnaissance aircraft of the period. The Aviation Ministry initially favoured Arado's proposal, reportedly even promising them the production contract before competitive evaluation began. Fokker-Wulf, led by the talented engineer Kurt Tank, submitted their FW-189 Uhu, which translates as Eagle Owl. Tank's design featured twin engines mounted on twin booms flanking a central glazed gondola that provided exceptional crew visibility. The configuration was unconventional, but logically derived from the visibility requirement. Both competitors violated the single-engine specification by submitting twin-engine designs, gambling that performance and visibility would outweigh the ministry's stated preferences. Neither Arado nor Focke-Wulf anticipated that an uninvited competitor would submit the most radical proposal of all. Richard Vogt approached the problem from first principles, questioning assumptions other designers accepted without thought. He examined conventional single-engine reconnaissance aircraft and identified three fundamental drawbacks that seemed interconnected. First, crew visibility was severely compromised. The engine blocked forward and upward views, wings obstructed lateral observation, and fuselage structure limited rear visibility. Second, propeller wash created aerodynamic disruption. The spinning propeller generated powerful airflow that struck the rudder and vertical stabilizer at an angle, forcing the tail sideways and requiring pilots to constantly apply opposite rudder pressure to maintain straight flight. Third, engine torque produced asymmetrical flight characteristics. The rotating engine and propeller created rotational forces that made aircraft naturally want to roll and yaw in one direction, forcing pilots to counteract this tendency with control inputs throughout every flight. Vogt recognized the paradox. Symmetrical aircraft designs didn't actually produce symmetrical flight characteristics. Pilots spent entire flights fighting asymmetrical forces created by supposedly balanced configurations. Vogt's breakthrough insight reversed conventional logic. If symmetrical aircraft flew asymmetrically anyway, why not design an asymmetrical aircraft that could fly symmetrically? His radical solution placed the engine and its torque-generating mass on one side of the aircraft, while positioning the crew gondola on the opposite side as a counterweight. The propeller wash would flow cleanly past the fuselage boom without disrupting tail surfaces, eliminating the need for constant rudder correction. Engine torque would be balanced by the offset crew mass and carefully calculated lift distribution across the wing. Most revolutionary of all, removing the engine from in front of the crew would provide unprecedented visibility. The observer and gunner would sit in a glass-enclosed gondola, offering 360-degree observation with virtually no blind spots. It was brilliant, unorthodox, and to conventional eyes absolutely insane. The BV-141's design featured a straight-edge wing mounted in standard monoplane configuration, with clipped tips to reduce drag. The port side of the wing connected to a slim fuselage boom, extending rearward from the engine to the tail unit. The engine itself, initially a WW1 in radial producing substantial horsepower, mounted at the forward end of this boom in conventional position. The starboard side of the wing connected to the crew gondola, a plexiglass glazed nacelle positioned entirely offset from the centerline. This gondola housed the pilot in front, the observer in the middle position with optimal downward visibility, and the rear gunner facing aft with defensive armament. The entire structure was covered in glass panels that provided visibility unmatched by any contemporary reconnaissance aircraft. Despite appearing unbalanced to casual observers, the design carefully distributed weight so that the wing's lift supported everything evenly. The asymmetry was visual, not aerodynamic. The tail configuration evolved through development, becoming even more radical in later versions. Early prototypes featured a relatively symmetrical tail plane, with horizontal stabilizers extending from both sides of the vertical fin. However, the final BV-141B version removed the starboard tail plane entirely, creating an asymmetric tail to match the asymmetric fuselage. This modification improved the rear gunner's field of fire by eliminating the horizontal stabilizer that had blocked certain angles. Critics claimed this change made the aircraft even more unbalanced, but flight testing proved the asymmetric tail actually improved handling characteristics. The BV-141. B also received a more powerful engine, the WW801, a 14-cylinder radial producing 1,560 horsepower, giving the aircraft a maximum speed of 272 miles per hour, a service ceiling of 31,008 feet 110 feet, and a range of 1,181 miles. Performance figures that exceeded many conventional competitors. The initial prototype, originally designated HA-141 before Blohm and Voss changed their naming convention, flew for the first time on February 25, 1938. Test pilots approached the aircraft with understandable skepticism. Every instinct developed from flying conventional aircraft suggested this asymmetrical design would be difficult to control, prone to rolling, and potentially dangerous. The takeoff run must have been tense as the aircraft accelerated down the runway, one side visibly heavier than the other, the whole machine looking ready to flip over. Then the wheels left the ground, and something unexpected happened. The BV-141 flew beautifully. Control responses were crisp and predictable. The aircraft tracked straight without constant corrections. Visibility from the crew gondola exceeded every expectation, with observers reporting they could see everything except a small area directly behind the engine boom. The asymmetric design worked exactly as Vogt had calculated. Flight testing continued through 1938 and 39, revealing both strengths and weaknesses. The strengths were undeniable. Visibility was exceptional, making the aircraft ideal for reconnaissance work. Handling qualities were good, with no tendency toward unusual flight characteristics despite the bizarre appearance. The offset crew gondola positioned observers perfectly for ground reconnaissance, while the rear gunner enjoyed excellent fields of fire for defensive purposes. Aerodynamic efficiency exceeded expectations, with the clean propeller wash flow actually reducing drag compared to conventional configurations. However, weaknesses also emerged. The initial engine proved underpowered for the aircraft's weight once military equipment was installed. The novel cockpit placement, while providing excellent visibility, left crews exposed with more glass surface area vulnerable to ground fire and enemy fighters. Wing design required modification to balance the additional weight of military equipment, necessitating strengthening and extension. The German Aviation Ministry's response mixed surprise with skepticism. Officials who had dismissed the design as impossible now faced test data proving it worked. On April 4, 1940, the ministry established that while the BV-141 mostly exceeded performance expectations, it still underperformed compared to ideal requirements. However, they acknowledged the design showed promise for reconnaissance roles. Luftwaffe Colonel General Ernst Udet, a World War I flying ace and influential figure in German aviation development, became the aircraft's most important advocate. Udet recognized that unconventional problems sometimes required unconventional solutions, and he pushed for continued development despite resistance from more conservative officials. Hermann Göring, Luftwaffe Supreme Commander and Reichsmarschall, remained unconvinced. Göring favored conventional designs and distrusted radical innovations that didn't conform to his understanding of proper aircraft. This split between Udet's support and Göring's skepticism would ultimately determine the aircraft's fate. Based on encouraging test results and Udet's advocacy, Germany ordered 500 BV-141s in 1939. For Blohm and Voss, this represented vindication. Their uninvited proposal had won a production contract despite initial mockery. The company prepared for mass production, developing manufacturing processes for this unusual configuration. However, reality quickly intervened. The Arado AR-198 prototype had failed testing and been abandoned, leaving only the Focke-Wulf FW-189 as serious competition. The FW-189, despite its twin-engine configuration violating the original single-engine requirement, performed exceptionally well in testing. Its twin-boom design provided excellent visibility, robust performance, and conventional flying characteristics that pilots found immediately comfortable. The Aviation Ministry faced a choice between the BV-141's radical innovation and the FW-189's proven effectiveness. Blohm and Voss continued development of the improved BV-141B version, incorporating more powerful engines and addressing weaknesses identified in early testing. 3 prototypes and an evaluation batch of 5 BV-141A aircraft had been completed, demonstrating the concept's viability. The BV-141B featured the more powerful BMW 801A engine, revised aerodynamics, strengthened structure, and the asymmetric tail configuration that improved rear defensive coverage. Between 1940 and 1941, 12 production examples were built and evaluated at various Luftwaffe facilities. Test pilots and reconnaissance crews generally praised the aircraft's visibility and handling characteristics. However, institutional resistance remained strong. Luftwaffe commanders worried about maintaining and operating such an unusual aircraft, questioned whether production could scale efficiently, and doubted whether crews would accept flying something so visibly unorthodox. The cancellation came in 1941, delivered through multiple crushing blows. First, the German Aviation Ministry decided that while impressive, the BV-141 couldn't be produced as efficiently as conventional aircraft designs. Germany's aircraft industry was already struggling to meet production quotas for established types, and introducing an asymmetric design requiring specialized tooling and training seemed unjustifiable. Second, Germany already possessed adequate reconnaissance capability through their stock of Focke-Wulf FW-189 aircraft, which performed their missions satisfactorily if less spectacularly than the BV-141. Third, the 12 production BV-141B aircraft featured BMW 801 engines that were urgently needed for FW-190 fighter production. Germany's fighter shortage took absolute priority, and diverting engines to experimental reconnaissance aircraft became impossible to justify. Finally, an Allied bombing raid destroyed the Focke-Wulf factory in Bremen that manufactured the FW-200 Condor, Hitler's personal transport and the envisioned heavy bomber for Soviet operations. Blohm and Voss production capacity was immediately requisitioned to take over Condor manufacturing, ending any possibility of BV-141 production. Ernst Udet's death in November 1941 eliminated the aircraft's most powerful advocate within the Luftwaffe command structure. Udet officially died by suicide amid personal and professional crises, though some historians question the circumstances. Regardless, his passing removed the one high-ranking officer willing to champion unconventional designs against institutional conservatism. Without Udet's support, the BV-141 had no defender when bureaucratic and strategic pressures mounted against it. Hermann Göring, who had never supported the design, saw no reason to continue development after Udet's death. The dream of asymmetric reconnaissance aircraft died with its champion, leaving only a handful of completed examples that would never see combat. German production records reveal that 20 BV-141B aircraft were actually produced rather than the widely reported figure of 12. This discrepancy stems from confusion between various prototype versions, evaluation aircraft and production examples. However, none of these aircraft ever saw operational combat service. Some were piloted only during 1939 and 1940 testing phases. Plans existed to deploy a reconnaissance squadron equipped with BV-141s to the Eastern Front for evaluation under combat conditions, but these plans were cancelled in 1942 when production ended. The aircraft that had been intended to revolutionize tactical reconnaissance instead spent the war in testing facilities and storage hangars. A few were used for continued aerodynamic research. Most simply deteriorated from neglect as Germany's strategic situation worsened. Allied soldiers advancing through Germany in 1945 discovered BV-141 wreckage at various locations. British forces captured at least one relatively intact example and transported it to England for technical examination. Intelligence reports from British aviation experts expressed surprise that such an unconventional design could fly so effectively, noting that German engineering had solved problems Allied designers hadn't attempted. Records suggest the United States Air Materiel Command obtained another BV-141 for testing and evaluation. American engineers studying the asymmetric configuration reportedly found the visibility and aerodynamic solutions impressive, though they concluded the design's complexity outweighed its advantages for mass production warfare. Tragically, none of these captured examples survived. Post-war, when their intelligence value had been exhausted, the aircraft were either scrapped or simply left to decay. Not a single BV-141 exists today in any museum or collection anywhere in the world. Richard Vogt's story didn't end with his aircraft's failure. Following Germany's defeat, American intelligence identified him as a valuable asset for aviation development. Operation Paperclip, the secret program that recruited German scientists and engineers to work for American interests, brought Vogt to the United States in 1947. He worked initially at the United States Air Force Research Laboratory in Dayton, Ohio, contributing to American military aircraft design projects. His expertise in unconventional configurations and advanced aerodynamics proved valuable during the early Cold War period, when American aviation pushed towards supersonic speeds and radical new designs. Between 1947 and 1954, Vogt worked on classified projects that remain partially obscure, though documentation confirms he contributed to vertical takeoff concepts and advanced wing research. From 1960 to 1966, Vogt served on the engineering team at Boeing, working under Chief Aerodynamicist George Scherer. At Boeing, Vogt's work focused on vertical takeoff systems, hydrofoil research, and most significantly investigations into wingtip design. he proved that small extensions attached to wingtips improved aerodynamics and increased operational range by reducing induced drag. This finding revolutionized aircraft design. Modern aircraft universally employ winglets, those distinctive upturned wing tip extensions, visible on virtually every commercial airliner and military aircraft. Every time you see an aircraft with winglets, you're looking at technology developed by the same engineer who designed World War II's most asymmetrical airplane. Vogt's final assignment at Boeing involved post-launch evaluation of the Boeing 747 design, ensuring the jumbo jet's revolutionary configuration would function as intended. He retired having contributed to aviation across 4 decades and 2 continents. The BV-141's legacy extends beyond its brief existence. It proved that asymmetrical aircraft could fly effectively, challenging fundamental assumptions about aircraft design. Modern aircraft remain symmetrical primarily for practical manufacturing and maintenance reasons, not aerodynamic necessity. The BV-141 demonstrated that engineers could solve visibility problems through radical configuration changes rather than incremental improvements to conventional designs. Its failure stemmed not from technical shortcomings, but from timing, politics, and wartime resource constraints. Had it entered service earlier, before the FW-189 became established, the BV-141 might have equipped reconnaissance squadrons throughout the war. Had Ernst Udet survived and maintained his advocacy, production might have continued despite efficiency concerns. Had Germany possessed unlimited resources, experimental designs could have been produced alongside conventional types. The 38 variants planned for the BV-141 never materialized. Design studies explored dive bomber versions, heavily armed ground attack variants, night fighter configurations, and long-range maritime patrol adaptations. Each proposal retained the asymmetric layout while adapting it to different mission requirements. Vogt believed the configuration's advantages, particularly the excellent visibility and clean aerodynamics, could benefit multiple aircraft roles beyond reconnaissance. However, with the base design cancelled, all variants remained paper projects. The most advanced proposals existed only as detailed engineering drawings that survived the war to fascinate aviation historians and enthusiasts. These drawings reveal how far Vogt intended to push asymmetric design principles, suggesting an alternate history where asymmetric aircraft might have become commonplace rather than historical curiosities. Today, the BV-141 occupies a special place in aviation history as the most asymmetrical aircraft to ever fly operationally, even if that operation remained limited to testing. Aviation museums worldwide display models and technical drawings, introducing new generations to this bizarre aircraft that challenged every assumption about proper design. Documentaries and books examine why it failed despite working so well, exploring the complex interplay between technical excellence and institutional acceptance. Modern engineers occasionally revisit asymmetric configurations for specialized applications, particularly unmanned aircraft where unconventional layouts might provide specific advantages. The BV-141 proves that sometimes the strangest solutions work precisely because they abandon conventional thinking that perpetuates conventional problems. Richard Vogt died in January 1979. His legacy secured not just by the asymmetric aircraft that bears his name, but by contributions across aviation's most transformative decades. From World War I biplanes to Boeing jumbo jets, from asymmetric reconnaissance aircraft to winglet technology on modern airliners, Vogt's career spanned aviation's evolution from fabric-covered wood frames to intercontinental jet transports. The BV-141 represented his boldest vision, the design that proved unconventional solutions could work when conventional approaches failed. That it never achieved operational success doesn't diminish its importance. Sometimes the most influential aircraft are those that challenge assumptions rather than win battles, that prove possibilities rather than deliver victories, that inspire future generations to question whether aircraft or anything else must conform to what has always been done simply because that's how it's always been done before.